You may have heard of percentiles if you've ever taken a standardized test in a public school. For example, the TCAPS. If you get your report back at the end of the year and it says you scored in the 89th percentile, that means you scored better than 89% of students in your grade level taking that test. Also, if you get that report back and it says that you scored in the 40th percentile, then you scored better than 40% of people taking that test, but that's lower than 60% of people taking the test. So percentiles are measures of location. There are 99 percentiles denoted from P1 to P99, and they divide a set of data into 100 groups with about a 1% of the values in each group. If you're looking for the percentile of a certain score, you just count the number of values less than that score and divide it by the total number of values, because you're finding the percent of scores that are less than the number that you're looking for the percentile of, and then you change that to a percent by multiplying by 100 or moving the decimal 2 places to the right. So a percentile is just the number of values less than a given value divided by the total number of values and then change to a percent. For example, this is a table that gives the number of chocolate chips in 40 Chips Ahoy cookies. It looks like they're sorted and range from 19 chips per cookie to 30 chips per cookie. So if we're looking for the percentile for a cookie with 23 chips, we would need to count the number of cookies that had less than 23 chips. Less than 23 chips would be everybody on this first row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cookies had fewer than 23 chips. So the percentile for 23 chips is 10 out of the 40 had less than 23 chips. 10 out of 40 is 0.25, and then 0.25 changed to a percent is 25%. When you say that 23 chips is in the 25th percentile, it means 25% or 1/4 of the cookies had fewer chips than that. So cookies with 23 chips is in the 25th percentile, means that 25% of all the cookies had fewer than 23 chips. Just like percentiles that divide the data into 100 groups, with 1% of the data being in each group, quartiles divide the set of data into 4 groups, with about 25% of the values in each group. Q sub 1 is called the first quartile. It separates the bottom 25% from the top 75%. Q sub 2 is the second quartile. It separates the bottom half from the top half, so it's the same as median. That's the definition of the median. And then Q3 is the third quartile. It separates the bottom 75% from the top 25%. We use quartiles to identify outliers, and I will show you that in just a few minutes. Here's an illustration of some data, and here are the 3 quartiles, Q1, Q2, Q3. Those quartiles divide the group into 4 sets with 25% of the data in each group. Again, Q2 is the median, and a new term for us, the interquartile range, is just the difference between the third quartile and the first quartile. So if you found these two numbers, you subtract them to get the interquartile range. There's an important set of numbers called the 5-number summary that gives some important characteristics of any data set. If you have a set of data, then, and I ask you for the 5-number summary, here's what I'm looking for. the minimum value in the data set, the first quartile that separates the bottom 25% from the top 75%, the second quartile, which is the same as the median, separates the bottom half from the top half, the third quartile, which separates the bottom 75% from the bottom top 25%, and then the maximum value. It's easy to get this 5-number summary on the calculator. We use OneVerStats, the same function that we use to find the standard deviation. 5-number summaries are useful in constructing box plots. We don't have time to construct box plots right now, but we're going to look at how you use this 5-number summary to identify outliers. To find a 5-number summary for a set of data that you've already saved in List 1, you just choose Stat, move your cursor to the right one to highlight Calc, and then choose One Variable Stats. As soon as you choose One Variable Stats, you'll go to a blank screen. You'll tell the calculator for what list you want it to calculate the 5-number summary. If you have saved your data in List 1, you just press second and the number 1 to choose List 1. You enter again and then scroll all the way to the bottom of the results to see the 5-number summary. Now, the first example that we did in, I believe 3.2, we found the mean for 8 NCAA football coaches' salaries, and then in 3.3 we found the standard deviation for those same 8 NCAA football coaches' salaries. Now we want to find the complete 5-number summary. I've typed those 8 salaries at the top of this slide so you can put them back in your calculator if you've erased them for some reason. I stored these 8 data values in List 1 in Stat Editor, and then I press second and quit to exit the Stat Editor. Then to get the 5-number summary, I pressed Stat, moved the cursor one place to the right until I had Calc highlighted. When I had Calc highlighted, I chose number 1 because it said OneVerStats, and then my calculator went to a screen that just gave me the OneVerStats, and I had to tell the calculator what list to use. So I pressed second and the number 1 because List 1 is right above the number 1 on my calculator. So again, stored the data in List 1 in your editor, press second and quit to exit the Stat Editor, and then follow this sequence here. Stat, highlight Calc, choose number 1, One Variable Stats, go to this screen, and then tell the calculator you want the One Variable Stats for List 1 by pressing second and the number 1 and then entering. I have to scroll down about 2 screens of data till I see this 5-number summary at the very bottom. Just hold down your down arrow, keep scrolling until you see the minimum value of the data set. That's the 150,000. The first quartile is $230,712.50 since we're talking about salaries. The second quartile is the same as the median. The median is $325,073 or $325,073.50, and the third quartile is $585,000. The maximum salary is $1,231,421. That was this salary. So min and max I could have gotten on my own very easily. Median, I could have just listed all of the salaries in order, picked the middle one, but the calculator has found for me the first and third quartile. So that's my 5-number summary right here. The min, quartile, first quartile, median, third quartile, and then the maximum. Next, I ask you to plot the first, second, and third quartiles on a number line with the salaries. Just to make this quicker, I have gone ahead and plotted all 6 salaries, and I've labeled how many thousands of dollars each one is. So this is 150,000, 229,000, 232,000, and so on. Now I want to plot the first, second, and third quartile. The first quartile is about 231-ish $1,000. It would be between the 229,000 and the 232,000. That's where Q1 is. The second quartile, or the median, is about 325,000. That would be about halfway between 300,000 and 350,000. That's the second quartile. And the third quartile is about 585,000. It's here somewhere. And do those quartiles divide the data set up into 4 equal groups? I had 8 salaries in all. How many salaries are below the first quartile? It looks like there are 2. How many salaries are between the first quartile and the second quartile? That looks like 2 as well. Between the second and third quartiles, there are 2 salaries. And then above the third quartile, there's 2 salaries as well, the 810,000 and the 1,231,000. So yes, those quartiles did divide the data up into 4 equal sets.